Okay, so I want to talk through the history of calculus. There's a fascinating story that is really, I think it adds a lot to understanding what is calculus and how is it just, I don't know, understood. So if we take a look at the story here, the big question that I have is, was calculus invented or discovered? This is going to be an overarching question that we'll hopefully be able to answer by the end or have some insight behind. And then we'll understand why is this even an important question at all to ask. So the history. So in the late 1600s, there were two mathematicians. So we have Sir Isaac Newton, which many of you maybe have heard of, and also Gottfried Leibniz. Now, obviously, their hairdos at that point were fantastic. That's just what I guess the brilliant mathematicians of the day looked like. So there are these two guys, Newton, Leibniz. We're going to try to understand what do they have to do with all of this. So let's understand Newton first. So Newton was English, and he was born in 1642. So if you want to make a little note of that, 1642 was when he was born. He was a late bloomer when it came to math, so he wasn't one of those child prodigies. So when he was 19 years old, so this was in 1661, he went to Cambridge and had little math background. So that's why I said, like, he's already 19 years old. He hasn't had that much math. He wasn't some type of child prodigy by any means. But he went to Cambridge, great university. One of his math professors, Isaac Barrow, showed Newton a way of what is called determining tangents at points. Obviously, that should clue you in of, ooh, okay, something maybe calculus related. So in 1665 to 1666, the bubonic plague hit London and closed Cambridge. Newton was forced into isolation on a family farm. So first off, date-wise, notice this is going to be 4 years into his college. So he's been learning math throughout this time now. And also, fun fact here, so this was during the bubonic plague. Obviously, during all of this COVID-19 things, you go into isolation and quarantine. They did the same thing there, except this is what Newton did. He basically discovered calculus, but we'll get to that point. So he was on his family farm, just in isolation. During these 2 years on the farm, Newton discovered/invented a mathematical method called fluxions, in addition to the law of universal gravitation and the fact that sunlight separates into a color spectrum. So obviously, very busy man. During those 2 years, that's what you can do in self-quarantine, is you basically discover calculus, understand universal gravitation, how gravity works, and that you get a whole spectrum of colors with sunlight, so you get rainbows and things. So, bravo to Newton. Okay, now, so he was a late bloomer, and he didn't start really learning math until 19, but then by the time he was 25, he was already a super genius. So kudos to him. I did not do this by the time I was 25. All right, now, so a little bit of information about what these fluxions are. So Newton described this method that are called fluxions of fluents. So he did not talk about calculus or any of these ideas that we are accustomed to. He said that what he described this as was time-varying quantities of a function at certain instants. So he was, in an essence, describing exactly what we mean of time-varying quantities of a function at certain instances. That seems to be like the derivative idea. At certain instants, time's changing. So this notation he used was this dots above. So we had x dot, this x with a double dot, x with triple dots. This should look maybe familiar to the little dash notation that we've been using for derivatives, but this is the notation that he used. Then in 1671, so this was already whatever 5 to 6 years after he went into isolation with this bubonic plague, he then compiled a whole synopsis of fluxional calculus. So he did basically this whole calculus concept by the time it was 1671. Okay, so remember that date, 1671, that's when he compiled this synopsis of fluxional calculus. Okay, now Leibniz, story of the other mathematician Leibniz. He was German, and he was born in 1646. His main pursuit was philosophy, which is where he was introduced to higher level math and law. So he wasn't strictly a mathematician per se, he did a lot more. So historically, a lot of these brilliant people did lots of different things through their knowledge. So he did philosophy and law. In 1672, Leibniz was sent to Paris for political and legal work. He stayed there until 1676. while he was in Paris. So during this time, so remember, Newton had his whole concept of fluxional calculus in 1671. Okay, so this is 1672 to 1676. Leibniz is studying math. In particular, the methods used to determine the tangent lines to certain classes of curves. Again, this should hopefully remind you of calculus. However, nobody knew how to derive the equation of the curve from knowing its tangent. So if you know the tangent, could you figure out what the original function is? So in 1673, he recognized that nearly the entire theory behind this is related to integrations. All right. So in 1675, then, he started introducing this notation of dx, dy, and this integral symbol. Again, this should be familiar. This is what we use. Furthermore, he began to recognize the relationship between integration and differentiation. Now, an important note is that, remember, in this class, we've had different notation for derivatives, right? We had this x prime, and we also had dy dx. They both mean a derivative, but Newton was using this x dots, and Leibniz is using this dy dx's. So he recognized that there's this relationship to integration differentiation, which we know. And now, what his approach was that everything he did with calculus was based off of sums. So this process of summing things makes sense when he was looking at integration. Side note here, limits were not introduced in formalizing calculus until 1754. So this is a lot later, right? Almost like 80 years later. Prior to limits, mathematicians simply noticed by ignoring small terms, everything just worked out fine. So that if they looked at, say, 1 over x just appeared, they were like, when x is really big, that just kind of goes away. So they had the intuition of limits, but it wasn't rigorously added. And so now we study it a lot more rigorously than the way that they did, because some things kind of get a little funny if you just simply are like, they just kind of work out magical. Not always, but for them it did. Now the drama begins. Now we have drama that takes place. So in 1684, Leibniz was the first to publish his invention/discovery of calculus. Okay, this is important, right? Leibniz was the first to publish. Okay, notice the year again, 1684. Wait a minute. Okay, so Newton had this whole fully functional calculus by the time it was 1671. This is 13 years later that Leibniz is now the first to publish this. The reason is that Newton did not like to publish his results. He was content simply sharing his ideas with his close friends. So he didn't care if anyone else in the world knew his ideas. He was just like, hey, buddies, let's talk about all of these weird ideas of fluxions and instantaneous rates of change and everything. Okay, so he did not publish, he didn't like to do this. Now, many historians believe that Newton was afraid of the ridicule he'd face with his crazy ideas behind calculus, and Newton was very known to hate controversy. So going back in time, people are able to understand that maybe Newton had a lot more insecurities behind things, as opposed to just simply being like, yeah, I don't want to brag. He was just a little bit more concerned about people judging him. Now, Newton did eventually publish his discovery/invention of calculus in 1693. So notice, this is now 9 years later in which he is publishing his view of calculus. Okay, so think about this from the world standpoint. You're, say, a leading mathematician scientist. You see Leibniz publish this incredible idea in 1684. 1693, Newton then goes ahead and publishes this. Okay, so you have some probably natural thoughts occurring. So now, even though Newton and Leibniz initially had no enmity with each other, and Newton was fine with Leibniz publishing first, Newton had some followers who did not like Leibniz. So basically, Newton has a little gang of buddies, and they were like, we don't really like Leibniz. Leibniz and Newton were fine with each other. They didn't really have any problems with them. But Newton had some nasty friends. Okay, so rumors began to spread that Newton was the first inventor/discoverer of calculus, and Leibniz copied Newton's results. So they were like, listen, Newton had this idea. Leibniz is nothing more than just a cheap copier. Really, all the credit should go to Newton. So in 1708, full-out claims of plagiarism were thrown at Leibniz. So this is already over 20 years after Leibniz published his results. Now everyone's like, yo, you are a plagiarizer. You did not come up with this. You just simply wanted to get the credit for Newton's ideas. Leibniz was like, listen, I mean, Newton's going to back me up, right? I didn't obviously copy him, so he expected Newton to basically have his back here. However, Newton, like we said, did not like controversy, so he said nothing. Thus, 4 years later, after these claims, investigations began. They wanted to know the truth. So back in 1676, when Leibniz was in Paris, he became aware of Newton's work. So let's try to figure out the facts of how could they justify any of these ideas. So Leibniz was in Paris. He heard of Newton's work. Leibniz convinced a mutual friend to have Newton write to Leibniz and to tell him the work that he was doing. So Leibniz was like, ooh, okay, we're working on a similar thing. Maybe Newton knows some things. So I'd like to be able to get some insight from Newton. So Newton did send 2 letters to Leibniz during this time, before Leibniz has his whole idea of calculus. In those letters, Newton discussed some of his ideas in a logical, step-by-step manner. However, where the steps that fluxions would appear, look what appeared instead. Okay, so now, even though there was communication between these 2 mathematicians, if you were Leibniz, you're reading through and all of a sudden you just see that. You're like, what? Obviously, Newton is not sharing any ideas behind fluxions or calculus to Leibniz. Now, in this time period, scientists would use anagrams as a way to establish priority of a discovery without revealing it. So this is what Newton was doing. He was trying to have his ideas without them being shared. So this was a Latin anagram. When unscrambled and translated, it said, given an equation involving any number of fluent quantities to the fluxions and conversely. Okay, so there is some meaning that if you could somehow unscramble this really crazy anagram in Latin, when Leibniz is English or Leibniz is German and Newton is English. All right. So since this was the only substantial evidence that Leibniz had access to Newton's findings before his own discoveries, historians agree with Leibniz and Newton's discovered/invented calculus independently of one another. We all agree now that they both discovered or invented calculus, but there was no influence that one had on the other. Now, the results then. The group who investigated the claims of plagiarism against Leibniz was the Royal Society. Maybe never heard of them. It was the highest council of scientists and mathematicians at the time in England, so they understood the whole process of how things were done. Newton was the president. Of the 11 people on the investigation committee, 7 of them were close friends of Newton. You might see where this is going. After only a month of investigations, which included no discussions with Leibniz, the committee was absolutely certain that Leibniz plagiarized Newton. It was clear as day, right? Now, this is the sad part. Newton remained the golden boy of England. Leibniz's math career was destroyed. When Newton died, there was a grand ceremony filled with lots of people. The only mourner at Leibniz's funeral was his secretary. So literally, all of Newton's buddies ruined the life and career of Leibniz mathematically, right? They just basically destroyed him, and they just only viewed him as a plagiarizer. However, Leibniz's greatest impact, he made major improvements for 2 of the strongest arguments for the existence of God. So he did do lots of really important things in the world of philosophy. These 2 arguments was the ontological argument and the cosmological argument. The ontological argument, loosely stated, argues that since God is maximally great in every possible way, and that it is greater to exist than not exist, that God exists. He did a lot of really legit logic to make this a very logically rigorous argument. This is one of my favorites. This is a really cool argument that God is maximally great in every possible way. It's greater to exist than not exist, so God exists. And the cosmological argument, as summarized by Leibniz, posed the question, why is there something rather than nothing? So it argues that since the universe began to exist, the only rational explanation is that God created the universe. So Leibniz had some really good, powerful things. So I'd like to make some concluding remarks here. These are the big takeaways I'd like you to have. So some first questions we have is, did Leibniz and Newton independently discover or did they independently invent calculus? We know that it was independently done. Historians absolutely agree on that. But the question is, did they discover calculus or did they invent calculus? Okay, so we have this difference between either discovering it or inventing it. If calculus it was discovered, so in my opinion, if we look at calculus, are we either discovering it as though it already existed, or are we inventing it as though it's just this human-made thing? I think it seems, at least from what I've seen, is that if you have two people independently discover it, it seems a lot more reasonable than independently inventing it. So I think the calculus is discovered. So the question we have is then, is all math discovered? So when we are doing mathematics and we're learning more mathematics, are we discovering it or are we inventing it? Is it already in existence and we're just uncovering and learning more about it, or are we just making this human contraption? As Christians, we can recognize that if mathematics is discovered, it is because math is either created by God or is a part of God's nature. So if math is already in existence, either God created it or it's just already a part of who God is. So for myself, I think this is a really interesting question. I remember wrestling with it for quite some time. So I really think that math is indeed a part of God's nature. So we have this question then, is math created by God or is math a part of God's nature? So either way we choose, we can see that by learning math, we can either further understand, appreciate, and worship God. So if we think that math is created by God, then that just helps us understand a little bit more of kind of who God is by understanding what he's created. If it's a part of God's nature, then as we learn more math, we're actually understanding more of who God is. And so for myself, I actually think that math is a part of God's nature. I think that God, like our God that we worship, is a mathematical God, that he has these mathematical tendencies, that the way he works creates logic, creates patterns. We can actually understand God's nature by doing more math. And so this leads me to worship God in a very unique and a very special way that those who don't understand math and don't delve deeper into math, they don't have the same appreciation. But I think calculus can help us point us to this direction that I think math is discovered, and by learning math, we are understanding more of who God is.